I'm Professor Gallagher, and welcome to Bluefruit School! In this lesson, we'll walk through the code we installed in the prior video and get a sense of the lines that even a newbie can modify to make the code their own, and we'll point out places where you can experiment further when you're ready to try and add new logic to execute when buttons in the app are pressed. If you're a complete newbie, make sure that you've gone through the earlier tutorials that are part of this Bluefruit School playlist. They'll show you how to configure a Circuit Playground Bluefruit or CPB, connect an LED strand to your CPB, and get the code on your CPB that will allow you to control lights using the free Adafruit Bluefruit Connect app that you can get for Mac, iOS, and Android. I also demoed that app showing you how it works with the code that I've written. Now, if you just want to build some of the projects in this playlist and you don't really care about coding in CircuitPython, then you've got what you need to move on to the next video. But you should watch this video to at least see where you can change the number of LED lights that you've got, just in case you've got fewer lights on the NeoPixel strand or strip that you're using in your project. And I'll also show you where you can modify the startup color used by this code. Now, for the curious, I'll also point out other parts in this code where the buttons that are pressed in the app are recognized by my code. This would be useful if you ever want to use my code as a starting point that you can modify for any future projects you might work on. I'm assuming that you've gone to the GitHub page, github.com/gallagher/bluetooth-mason-jar-light, clicked on the link for code.py, that's our code, highlighted and copied all of the code, pasted it into Moo, and that you've plugged in your CPB and saved your code to it with the name code.py. Now, I'm not teaching all of CircuitPython in this video, but I do have a playlist on my YouTube channel that has lots of CircuitPython lessons if you're interested in that. Here, I'm just going to point out some key lines that I've written, because one of the fun things about being a maker and programming electronics is that once you recognize some code, you can begin to experiment with that code, modify it, and make a project your own. So to be a successful electronics maker, you don't have to be a code it all from a blank sheet programmer. You just need a basic understanding, and you can keep experimenting and tinkering from there, and if you do this, you'll find that your skills will grow over time. So let's take a look. And always remember, if you experiment with changes and you've changed something and all of a sudden your code doesn't work, you can always get a copy of this working version from GitHub. Now, as we start to look through this code, the first thing we see are a bunch of lines that start with a number sign or hashtag. Now, the number sign is the comment character in Python, and anything after the number sign on a line doesn't execute as Python code. Instead, it acts as documentation. It's good practice to use lots of documentation to describe how your code works. So if you want to get a sense of what the program is doing, I've documented this code. You can read through the code paying attention to the comments. Now, you'll also see that there are a bunch of colors if you scroll a little further. They have names. Now, we're not using all of these colors, but if you decide you want to change the default color that shows up when you first power your project on, look for the color that you want to use and remember the name. All of these names are in all caps, so you have to remember to enter them in all caps with this exact spelling. Then if you scroll further down here, you'll find a line that says default color equals, and in all capital letters, amber. And if you decide you want to change amber to blue, you can highlight amber and you can change that to the word blue in all caps. Now, if I were to save this file with the name code.py to my CPB, now here's something to note. Sometimes Moo's a little flaky. For some reason, the save as didn't take effect. I can tell that because the red indicator is still on the tab indicating that the code wasn't changed. We mentioned that in the previous video. But if I click on the save button up here, the red dot goes away, the change is saved, the code executes, and the lights change from amber to blue. Also, if you're experienced with Moo and CircuitPython, and those who have gone through the Introduction to CircuitPython playlist know this, if you click on the serial button up here, it opens up a serial console or serial monitor, and this provides information on what's going on the device that this code is executing on. So in this example, it provides what's going on in our Circuit Playground Bluefruit. Also, if we had any print statements in our code, this is where the output would show up. So if we press save again to restart our code, we don't see that there are any error messages here. If we did have an error in our code, it would show down here. And if you don't know about this, to learn more about how this works, you can check out the Introduction to CircuitPython playlist. I'm just going to click on serial again to close this window. Everything is looking good. Now, another important line down here is the one that says num_LEDs equals 10. Now, if you have a different number of LEDs in your NeoPixel strand, you can count them up. Say there are 20 in your strand instead of 10, then you can replace the number 10 here with the number 20. Save changes again, that causes the code to re-execute, and we see all 20 lights light up. I'm going to undo those last changes and resave this because I want the code to remain just like it is when I run the next video. Now, I also want to point out this line up here that says advertisement.complete_name equals jar-light. Now, this is supposed to be the name that shows up in the Bluefruit Connect app so that you can easily identify your project, but as I mentioned in the previous video, unfortunately this doesn't always work reliably, and sometimes you'll just see a device listed with a name that begins with CircuitPy. But this could change in an update to the CircuitPython language, and if you ever want to return here and give your project a different name, like say Smart Tie or Smart Scarf, you could do that right here. Just, and this is very important, make sure that the name between quotes is no larger than 11 characters. If it's bigger than 11 characters, then the Bluefruit app might not recognize it. Now that might be all you want to know, but if you ever want to experiment with changing what executes when the buttons in the Bluefruit Connect app are pressed, then scroll past this part that says def run selected animation. That's a Python function that I wrote that's called whenever we want to execute any animations, and keep scrolling down until you see this part of your code that says while true : Now this is the main loop in our code. Most of the CircuitPython programs that you read will have an area of the code that starts with while true : and that's just a way to ensure that everything that appears after this statement will execute over and over again until the device stops. If it's shut off, if the power goes off, you can also stop the code if the code is running in moo and you press Control-C, or if there's a bug in your code that causes it to crash. Now to find the code that executes when specific buttons are pressed on the Bluefruit Connect app, if you scroll further down here, you'll see sections that say if packet.oneButton equals button packet.button_1. Now this is definitely Python code that you're looking at, but you can read this if statement as saying when button 1 is pressed in the Bluefruit Connect app, and this is a screenshot showing what that app looks like, then execute the lines that are indented below this statement. Now there are two lines, and you can see the first one says animation_number equals 1, and it also sets a value run animation equal to true. Now in this program, I use the animation number to run a specific animation in a block of code known as a function. I'll show you that in just a bit. Now I'll also show you that by setting a run animation equal to true like we do here, then that'll be used to check to see if it's okay to run whatever animation number we just pressed. Now if you ever want to modify code, this is what you should remember. When you learn to write code to control motors and you ever want to make a servo motor move or to add code to play a sound, you could put this code after if button packet.button_1, and any code that's indented under this line will execute when button 1 in the Bluefruit Connect app is pressed. So if you didn't want anything to do with these animations, you could cut out these two lines and replace them with your own code. Say if you wanted to play a sound when button 1 was pressed, just make sure that they're indented at the same level as these lines are right after this if statement. Now if you scroll further, you'll see elif statements that follow the statements below. Those will execute if button 2, button 3, or button 4 in the app are pressed, and these set the animation number to number 2, 3, and 4 respectively. Now I also have code set up to respond to pressing the arrow buttons. The lines indented below this line will respond if either the up arrow button is pressed or, see the or in here, the down arrow button is pressed. So this one line checks to see if one button or the other button is pressed. Now further down in this code, the code that's indented below this line executes after the right button is pressed. The code indented after this line executes after the left button is pressed. Now the code here might seem a little bit complex, and if you saw the previous video, you know that the up or down arrow stops the animation and lets you move a single light up or down the strand of lights in your project. And you also saw that the right button speeds up animations and the left button will slow down any animations as they run. Now there's nothing special about these buttons because they have arrows on them. They work just like the previous 1 through 4 buttons. Whatever I program after recognizing the button is what will execute when that button is pressed. Now you could cut out all of the code that's indented after each of these statements that checks which button was pressed if you didn't care about moving lights forward or backward, or you didn't care about the speed, and you could replace that indented code with any code you wanted to do whatever you want. If you know how to program a different animation or how to program to play sound, just add that code here. So what are these animations, the animations numbered 1 through 4? Well, if we scroll down in our code, we see this line that says if run animation equals true. Remember, we set run animation equal to true if you pressed on button 1 through 4. So we said, hey, this is when we want to run an animation, and we gave it an animation number. Now, underneath this run animation equals true, we have a line that says run selected animation. Now, that's actually the name of a function that I've written, which we can find in our code. We've got to scroll up. It's actually up here and outside of the while true loop. So scroll beyond that. And do you see this line in Python that says def run selected animations? Well, that's where we're defining our function, and anything that's indented after this run selected animations line here is part of that function. That's going to execute whenever we write the line in our code that says run selected animations. And in here, we see an if statement to check to see if the animation is 1, elif, number 2, elif, number 3. This is where we actually execute the animation that's associated with the button that we pressed. So in this first statement here, if the animation number equals 1, we create a value comet animation that creates an animation using the statement C comet. Now, comet is an animation that Adafruit created. I didn't write that code. Now I can use a statement in here because I imported Adafruit LED animations, the library, at the start of my code, so I didn't write comet, Adafruit did, but I can take advantage of that because I imported the library. So we take the result of the Adafruit comet function and put it in this value comet animation, and then we set the comet animation to animate exactly once. Now I don't want to get too complicated here, so if this is too complex for you, you can just ignore it, but by saying animate once here, we actually pause after one cycle of the selected animation, and then we check to see if the user has pressed a different button in the Bluefruit Connect app. They might have pressed a different number, pressed one of the arrow buttons, they might have gone back and selected a color. But if they don't make the selection, we'll continue to run the animation over and over again. Now watch what happens when the app is running. We've set button 1 to execute comet when button 1 is pressed. And if we take a look down in the elif statement for animation equals 2, which happens when button 2 is pressed, this sets the animation to one called pulse. Button 3 sets the animation to one called sparkle pulse. And for button 4, I've actually set up 3 animations to execute together, one after the other. That's rainbow, rainbow sparkle, and rainbow comet. All these 3 run together, one after another. Now I'll point out one more thing in our code. Remember, this code is set up to work with the Adafruit Bluefruit Connect app. And inside of the while true loop that's back down here, there's another line that says while ble.connected. Now what this means is that all the code that's indented below this line will execute while the project is connected to our Bluefruit Connect app. So while ble.connected means while the project is connected to the Bluefruit app. And below here, this is where we check to see if the color was changed or if any of those buttons was pressed. And we also check to see if we should run the animation because a button was pressed, and if so, we call the run selected animation function. But what happens if our project is no longer connected to the Bluefruit Connect app? This might happen if the user shut down their iPhone, if they shut down the app, if they walked out of Bluetooth range. Well, if that's the case, then this statement here, while ble.connected, is no longer true because we're not connected. So we stop executing all the lines that are indented below this statement. We were executing them over and over again. Instead, we head back up to the top of while true, and we restart the code from right after while true. And then when we hit this line here, while not ble.connected, well, it's now true that we're not connected. So what we do here is we check to see if we should still run animations. So has the user pressed a button to start an animation, and did they do that before they disconnected? And if that's true, we keep running the selected animation over and over again. And we'll continue to do that until someone connects to the app. And when we connect to the app, it's no longer true that our code is not BLE connected. So we are connected. So we stop executing this block here, this while not BLE connected block, and we continue to execute what's below that, so we skip past the stuff that was indented. Then we hit this line here that says while BLE.connected. We keep listening for another button to be pressed, so maybe the button that changes the color, or the number buttons, or the arrow buttons. And then down here, while we're still running the animations, we'll continue to run the old animation, or if a new animation was selected with one of those buttons, we'll run selected animation. We'll just take the new animation number and switch the animation to that animation number. Now, I'm not sure if you understood all of the explanation that I just gave, but if not, feel free to go through the CircuitPython lessons, and that playlist will introduce a bunch of the basics of the language like variables, functions, while loops, how to use RGB color numbers, and lots more beyond that. But even if you understood just some of this, remember you could come back to this video and rewatch it whenever you want to experiment more with this code. And also know that any of Adafruit's programming libraries have documentation online too. Now this documentation is meant more as a reference than a tutorial, but if you search for read the docs, all one word, plus the name of the particular CircuitPython library that you want to import and use in your code, like here we have Adafruit LED animations, well, you should be able to find a reference page like this one, which is the reference page for the library that I just searched on, Adafruit LED animations. And you can scroll through this to see all of the different statements that you have access to when you import this library. So hopefully, this video was a helpful introduction on how this code works, and you should at least be able to change the default color and the number of LED lights to fit the number of lights that are in your NeoPixel strand. And many of you are also now armed to be able to use this base code so that you can modify it and do all sorts of fun things using the Adafruit Bluefruit Connect app. Tutorials for the mason jar light, the Bluefruit connected scarf, and the Bluefruit connected necktie follow. Now get out there and make something awesome.